In this tutorial, we are going to prove these very simple results. We will give a generic proof of all these three, that if we multiply two even numbers, any two even numbers, the result is always an even number. If we multiply any two odd numbers, the output is always an odd number. And if we multiply any odd number with any even number, the output is always an even number. So let's get started. We are going to prove that the product of two even numbers is even. So we already know that if we multiply two even numbers, the result is even, right? But here we have to prove it, okay? Let's talk about it. We know that every even number can be written as 2 into n, means 2 into an integer. So n is an integer, right? For example, 2 is equal to 2 into 1, 4 can be written as 2 into 2, 6 can be written as 2 into 3. So 2 into an integer, right? So what we have to prove is that if we multiply two such numbers, then the result is also of the same form. So this is very easy to prove. So let's do it quickly. So let's take two even numbers. So let A and B be the two even numbers. Okay. So if A and B are two even numbers, then definitely I can write A as 2n and B can be written as 2m, right? Where both n and m are integers. Why n over here and m over here? Because these two can be two different even numbers. For example, a can be 4, which can be 2 into 2, and b can be 6, which should be written as 2 into 3. So this is my n, this is my m, so these can be different. Fair enough. Now we have to take a product of these two numbers. So let's multiply these. Now a into b should be equal to, so we have to multiply this and this because this is a, this is b. So this will be equal to 2n multiplied by 2m, which is equal to 4nm, but we can write it as 2 into 2nm, right? We can write it like this. Why do I want to write it like this? Because I have to prove that it is of the form 2 into an integer. Now this is an integer because 2 is an integer, n is an integer, m is an integer. So if I multiply integers, then the output is also an integer. So let's call it r. Okay, so let's name it r. So we can write it as, so this is equal to 2 into r, where r is 2 and m, and definitely r is also an integer. And that's what we had to prove, that if we multiply two even numbers, a is an even number, b is an even number, then the output is also even because it is of the form 2 into an integer, right? We are going to prove that the product of two odd numbers is always odd. So this is very easy. We already know that if we multiply two odd numbers, the result is always odd, okay? But we have to prove it. So it should be a generic proof. So let's talk about the odd numbers first. So we know that every odd number can be written in this form, 2n plus 1, where n is an integer, okay? So n belongs to set of integers. For example, 5 can be written as 2 into 2 plus 1. 7 can be written as 2 into 3 plus 1. So this is my n, right? So this is n. Now what we have to prove is that if we multiply two such numbers, the result is also of the same form. So that's what we have to prove. So let's do it quickly. So let's take two odd numbers. So let a and b be the two odd numbers, okay? So if a and b are two odd numbers, then definitely I can write a as 2n plus 1 and b can be written as 2m plus 1, where both n and m are integers. Okay, so why n over here and m over here? Because these two can be two different odd numbers. For example, 3 can be written as 2 into 1 plus 1, and 5 can be written as 2 into 2 plus 1, right? So this is n and this is m. So these can be different. Fair enough. Now let's multiply these two because we have to find the product. So now a into b should be equal to, so we have to multiply these two, right? Because this is a, this is b, so it will be 2n plus 1 multiplied by 2m plus 1, and this will become, let's multiply it, so it will be 4nm plus 2n plus 2m plus 1. Now this is an even number, this is an even number, this is an even number, so let's take 2 common, and inside it will be 2nm plus n plus m and then plus 1. Now if you look at this part, now 2 is an integer, n is an integer, m is an integer, so this will produce another integer plus an integer plus another integer, so this entire part will give me one integer. So let's call it r. So if I call it r, so this will be written as 2 into r plus 1, where r is an integer, right? So that's it. That's what we wanted to prove, that if we multiply two odd numbers, so this is an odd number, this is an odd number, we multiply two odd numbers and the result is of the form 2 into an integer plus 1, which is again an odd number, right? We are going to prove that if we multiply an even number with an odd number, the output is always an even number. We already know that, but now we have to prove it. So let's talk about it. We know that every even number can be written in the form 2 into n, where n is an integer, and every odd number can be written as 2n plus 1. For example, 8 can be written as 2 into 4, so 2n, right? So this is n, an integer. Similarly, 9 can be written as 2 into 4 plus 1, so this is of the form 2n plus 1. Now what we have to prove is that if we multiply one such number with another number which is of this form, then the output will be of this form. So that's what we have to prove. So let's prove it quickly. So let's take one even number and one odd number. So let a be an even number and b be an odd number. Okay, so a is even and b is odd, so definitely I can write a as 2n and b can be written as 2m plus 1, where both n and m are integers. Fair enough. So let me tell you once again, don't get confused why I used n over here and m over here. Their values can be same, but these can be two different numbers as well, right? For example, a, if a is 6, then it is 2 into 3, and if I take, say, odd number is say 11, then it is 2 into 5 plus 1, right? So this number is different, this number is different, so that's why we generally write n over here and m over here, because these two can be two different numbers. Okay, fine. Now we have to take the product of these two. So now let's multiply a and b. So this will be equal to 2n multiplied by 2m plus 1, right? So this is a and this is b, so we have to multiply this with this, so this is 2n into 2m plus 1. So let's open it, so it will become 4mn plus 2n, right? Now this is an even number, this is an even number, so let's take 2 common, and inside it will remain 2mn plus n, right? So I just took 2 outside, only 2, because I just want to prove that this is again of the form 2 into an integer, right? Now 2 is an integer, m is an integer, n is an integer, so definitely 2mn is an integer, and then integer plus integer will again be an integer. So let's call this as r. Okay, let's name it r. So we can write this is equal to 2 into r, where we know that r is also an integer, right? So that's it, that's what we wanted to prove. A is an even number, right? A is an even number. B is an odd number which is of the form 2m plus 1, but their product is of the form 2 into an integer. So 2 into an integer means this is an even number, right? So that's it from this tutorial. Keep watching Mathemafia.